In a previous video, I discussed the 5 stages of software development, at least as far as I define them in working on a simple application. We have a planning stage, interface development, coding stage, testing and debugging stage, and deployment stage. The interface development, the coding, and the testing and debugging are largely cyclical. We're going to develop the interface, we're going to code it, we're going to test it and debug it, and in debugging it, we may have to go back and make changes to the interface, or most likely make changes to the code. We may go through that process many, many times, and probably the more complicated an application is, the more times we'll go through that. In terms of working with Visual Studio, the interface development, the coding, and the testing and debugging are done within the Integrated Development Environment, or IDE, of Microsoft Visual Studio. And deployment is also going to take place somewhat in Visual Studio, in that we're going to create executable files within Visual Studio, and then we'll decide how we're going to deploy those. The planning stage happens outside of working with Microsoft Visual Studio. I'm largely going to do that with paper and pencil. Sometimes, if it's a simple application, I may just do that planning in my head. For now, it's good practice, though, to get into the habit of sitting down with a pad of paper and planning out what your software is going to look like and how it's going to function. In your previous computing classes, you learned about the 4 different components of hardware. We have input, we have processor, we have output, and we have storage. With input, we have devices such as keyboards, mice, maybe a Wacom tablet. You might have a computer that's connected to weather sensors, such as looking at the temperature or the wind speed. That's all ways of gathering input and bringing that input into the processor, where it is worked with the central processing unit, or CPU, which is the brains of the computer. That's where our program is going to run, is inside that processor. And then from that, it's going to generate some output. Typically, output's going to a monitor or LCD display or data projector. We might print that output to a printer or plotter. Or in terms of music, it might go out to an audio speaker. A computer might also have a storage device, most of them do, in which we can store data for future reference. We're going to typically store that information on a hard drive or a flash drive, sometimes referred to as a USB or thumb drive, a DVD or CD, and then more and more we're storing stuff in the cloud on the internet. In terms of computer software, we have those 4 same functions. And in planning for an application, we need to look at what are the things that are being provided for each of those. In terms of input, I want to know what is the provided input. What's the user going to give me to work with? Or what data am I going to have to be able to process? And then what's the desired output? What do we want this thing to generate? And then the big question is, how do we get there? How do we get from that provided input to the desired output? And that process is referred to as an algorithm. This is where the coding comes in. We're going to code in such a way we can take that input and generate the desired output. Algorithm is nothing more than a big fancy word for the steps of a process. And then finally, do we need to store that data and be able to recall that data? In terms of this class, data storage is going to come much later in the semester. For now, we're going to create simple software that has input, output, and a process to get between the two. In creating an application, we're going to probably sit down with the client and determine what are the needs. What should this thing do? What is going to be provided? How should it look? And what format should that data be in? Now we're going to create, over these next several videos, a very simple calculator within Visual Studio, just so you can see the process that I would go through in terms of developing an application. So here we're going through the planning process. Now the interface we're going to develop is not going to look anything like a normal calculator. We're going to keep it much more simple than that. But the 4 things it should be able to do is to add, subtract, multiply, and divide 2 numbers. The input that's going to be provided is 2 numbers by the user. We're going to refer to those as the first number and second number, and I've labeled those A and B for the purpose of planning. And then what is the output? Well, the output is simply the answer of whatever operation they choose. Those operations are those four things of add, subtract, multiply, and divide. So if they choose to add the two numbers together, I'm going to have an algorithm that looks at or determines I have to get A and B from the user. I've got to calculate the solution of those two numbers added together. And then third, I've got to display that value back to the user. In doing a multiplication button, it's basically going to be the same thing, except rather than adding the two numbers together, I'm going to multiply the two. Now that process, or that algorithm, is represented here by pseudocode. Pseudocode is not true code. It's simply English language that says, here are the steps I need to go through to get from point A to point B, or to get from the input to the output. Some programmers like to display their algorithms graphically using flowcharts. I typically write flowcharts out with paper and pencil by hand. You can get a template in a college bookstore or in an office supply business that will allow you to draw these symbols very nicely. There's also software out there such as Microsoft Visio that does a great job of creating flowcharts and adding in the text. There are various symbols that are traditional and used in a flowchart. I've got 3 of them here. You see the cigar-shaped symbol, which provides the start and the end. This is called a terminal symbol. So every flowchart is going to start with it and end with that symbol. Then I've got a parallelogram here. Parallelograms are used for showing input and or output. So here I've got some input. I'm going to get the two numbers that the user is providing. I've labeled A and B. And down here I've got the output. I'm going to display that answer, or the value of C, back in my application. And then I have a rectangle. Rectangles represent an internal process. So the internal process here is I've got to take those two numbers and calculate the answer. You also see lines between these symbols. This is the flow of the program. In this case, this is a strict linear flow. And we'll see later there are other symbols that allow us to have multiple paths for a flowchart to follow. You use algorithms every day. Again, algorithms are nothing more than the steps of process, and the steps are very important. In baking a cake, we wouldn't want to substitute salt for sugar, even though the two look kind of similar. We also, the order of those steps is very important. We wouldn't want to try to add the eggs in after we've baked the cake. Same with changing a tire. Safety is of utmost concern here. And if I fail to put the lug nuts back on after changing the tire, it's going to be disastrous, maybe even life-threatening. If I try to jack the car up before I loosen the lug nuts to take the tire off, the tire is just going to spin. There's no friction of the tire being on the ground to hold the tire in place. So the process, the order of that process, is extremely important in order for it to be successful. We have algorithms that we use when we pack for a vacation, and also algorithms when we take a photograph. I want to set the speed of the camera, or the shutter speed, and the aperture. Maybe add in some special effects. I might want to turn the flash on or off, depending on the light settings. Those are all parts of the algorithm of taking a photograph.